Welcome to a new test and teardown video. Look at this beautiful oscilloscope. It's just so fantastic. I really love the layout and the design. Everything is just wonderful. The handle here is really thick and stable, and you can just grab it like that. It's nice and shiny, and yeah, I'm just totally in love with this one. And you know what? I got the full manual for it as well, and it is in a really good condition. So I think I will scan this and put it online if I cannot find this already. And of course, you know this, but Teartronics. All right. So this is why it is nice. I don't know. Maybe it is. So this Telequipment D61A is from 1975. And I really need to open it first. I cannot plug it in because I hear some loose parts inside. So that is not the best way to start, is it? So that was easy. I just took out the rear cover. So that's a loose screw, and that is probably the one holding this cable. So there's probably also a nut inside somewhere. And then I'm like, how are we going to open this? See? These are not for opening. But here, the side panels. I need to go and investigate a little bit more here. How are we going to open it? So that's the voltage selector. Some adjustments for high voltage. That will be the bottom part of the transformer, I would assume. A little bit of spider web, and that's it. So that will be focus, and here is a brightness and power on switch, nicely located all the way to the back. So the way to open this is just pull. The sides locks into some mechanical things here, and then you just pull it out the back. So that will be the circuit board. And it's not a big surprise, but it's of course all transistors, and they're all in sockets. And this is very normal for the beginning of transistors, because you can imagine all designers, they have been used to radio tubes, and they are of course always in sockets. And then transistors, yes, of course we need sockets because we don't know how long they last. Maybe they only last 5 or 10 years, and we maybe need to replace them. So that is why they always put transistors in sockets in old equipment, because they never knew. It's full of, I think, field effect transistors here in the analog input. Oh, look at that, I found it. That is what I came for. This little nut here. Now I feel I can turn it on. The other side of the unit, we can easily see the bottom side of the circuit board, and we can probe around and solder around and do surface. It's not that bad designed after all. And I've been trying to find any reason why I can't power this up. And there is nothing really. There's a few things where it's a little bit close with the isolation distance. But yeah, I think it's okay. I'm I'm a little bit sad that the way that they assembled the case here. I mean, you can't get in here and do a service on this potentiometer here and that one without, okay, then you just drill these out and then you put in a screw. I mean, it's not a big deal, is it? Oh, there's some really cool thing I really want to show you. Look at that one. Trace rotate. So the idea is, here you rotate, but there's something I think is not working, because shouldn't that rotate the entire CRT? But it's only rotating some plastic part down here. It's not rotating this screen. I mean, maybe I need to I don't know, maybe those needs to be tightened a little bit more so it grabs a little bit better on this piece of metal in there, right? Because of course it should rotate the screen, but I feel like I can just power this up. Let's do that. Let's try and power this on. I will dim the light. Power is in here, and then we got some green light here. It's using 18 watts. We got a beam. And it's nice and bright. Here's focus. Oh, good focus is in the middle. So how do we move the, here's the beam left and right. We need a little bit more deflection, I would assume. So this is, okay, this is channel 2. Oh, that potentiometer here needs a little bit of exercise, but we got 2 channels. Let's try and give it a little bit of input. All right, I need to go and clean some potentiometers, and then we will see what is going on here. Why haven't we got a little bit more? Oh wow, there's a beautiful picture. Just this potentiometer here is really bad. Let's go to the other one. Let's see how's, click that channel off, and then okay, channel 2 trigger, and then like that. Okay, so this potentiometer here is a little bit better, and that's of course because channel 2 is not, well, haven't been used so much, right? And you can pull, what can you do? Yeah, here you can. Haha. Yeah. What a nice oscilloscope. And I think this little green indicator here is a little neon bulb with some green stuff. Whoa, that is nice. So let's try and see how it goes with a little bit of contact chemical magic. I've been adding a little bit of chemicals to all these. We are now in channel 1. Pull for auto level. Okay, whatever. And then here's the position C. So that is nice. Now it's just this. See, I didn't clean the other switches. But contact cleaning is definitely a thing. See? It is not a lie. So let's try and play with this trace rotation. If I see, it has absolutely no effect, but it is almost perfect. Now I'll go and play a little bit with this, and I will see if I can. I think, shouldn't I have a little bit more? I will definitely go and check the frequency. So this is 1 kilohertz. So that means if I am in 500, I can play a little bit with the. See, it should have been. See, I need more. That is the thing. I need to figure out how to get a little bit more width, because timing here is a thing, and it has something to do with that. Well. So I think this is more or less what I wanted to show you guys about this oscilloscope from 1975. Thank you very much for watching, and I hope you like this fantastic design as much as I do. I really think this one is super, super nice. Bye bye. Hope to see you again in a couple of days maybe.